This is my geometry course. Today we're going to continue to learn area. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start by finding the area of regular polygons. Remember, a regular polygon is a polygon where all the sides are congruent. And we're going to find the area of those. And to do that, we're going to need to use these terms: the center of a regular polygon and the radius of a regular polygon. Now, we typically only think of center and radius with circles. So what are we talking about when we say the center of a regular polygon? Well, if you draw a polygon inside a circle, that's called an inscribed polygon. Inscribed means inside. And the circle around it, the circle on the outside, is circumscribed. So circumscribed means outside, whereas inscribed means inside. So this is a circumscribed circle. And if you draw a circle around a regular polygon, this is not a regular polygon, this is just a random polygon. But if you draw a circle around a regular polygon, that's not a perfect circle, obviously, but the center of the polygon is considered to be the center of the circumscribed circle. A segment from the center to a vertex of the regular polygon, you can see that that's the radius of the circumscribed circle. And so we say that this is the radius of the polygon. So that's what all that terminology means. So you can see we have this information here. We have the center of this pentagon, using that as an example. And we have the radius going from the center to a vertex. And there's one more thing that we need to know. We need to know the apothem. The apothem is the distance from the center of the polygon to the side. So that's a perpendicular segment. Now, an apothem is a segment, this segment, but the word is also used to describe the length of the segment. So if somebody says find the apothem, they mean find the length of this segment. So let's talk about how we're going to find the area. And by the way, you can take screenshots of these if you need to. Probably best to go ahead and do that. Take a picture with your phone. You can have that right in front of you as you go along here. So finding the area of a regular polygon, the concept is very easy. You just draw the center and you create triangles by drawing segments to the vertices. And you can see in a pentagon we have 5 triangles, and it turns out that all these triangles are congruent. And so we just have to find the area of one of the triangles and then multiply by 5 in this case. Now, how do we know that these triangles are congruent? Well, it's pretty easy. This is a regular polygon, so we know all these sides are congruent. And these are all radii of the circumscribed circle, so they all have to be congruent. So we can use the SSS triangle congruence postulate to say that all these triangles are congruent. So we can just multiply the area of one of the triangles by 5. Now, we have to find the area of each one of these triangles, but in order to do that, we have to have the base and the height. In this particular problem, we don't have the base or the height. We have the radius of the polygon, and that is this length here. So these lengths are all 2. So we don't have the base or the height of any of those triangles. But what we're going to do is we're going to drop down an altitude. Whoops, sorry about that. We're going to drop down an altitude, and we're going to, again, find the height and the base. And we're going to use, we have right triangles now. We're going to use the hypotenuse of the triangle, which is the radius, and trigonometry, the sine, cosine, and tangent stuff, to find the base and the height. Now, in order to do that, we have to show, just as we did in the previous class, we have to show that this triangle is congruent to this triangle, and that's pretty easy. You just use the hypotenuse leg theorem. So that means that this length is congruent to this length, and this angle is congruent to this angle, and so on and so forth. So let's show how we're going to do that. So the first thing we're going to do is we're going to drop this down and use this angle. We're going to find this angle somehow, and this side to find the height and the base. So that's our task. But how do we find that angle? Well, here's what we do. We take 360 degrees, because that's the total rotation of all this stuff, right? 360-degree rotation, and we're going to divide 360 by 5, because all these angles are congruent, because those triangles are all the same. These triangles are all the same here, you see. So step 1 is to find the measure of angle A. I'm going to call this angle A. So the measure of angle A is equal to 360 divided by 5, which equals 72 degrees. So now that we have that angle, I'm going to go ahead and copy this triangle. And so again, this angle here is 72 degrees. And then I'm going to drop an altitude, take that triangle out. Again, these triangles don't have to be perfect, but as we did in the previous class, we're just going to take this triangle out and put it here. And this angle here is 72 divided by 2, which is 36 degrees. And again, that's just because these two triangles are congruent. They're both right triangles. And so the corresponding parts are congruent, which means that this angle must be equal to this angle. So just divide 72 by 2 and get 36. Now we know the radius is 2 meters. So we're going to put 2 right there. And so we're looking for the base and the height again. So this is going to be the height. And we call this length x as usual. And this length would also be x because, again, they're both congruent right triangles. So that's x. And then we're going to find the height of the triangle. And you should be aware that you can find the area of this triangle and then multiply it by 10, or you can find the area of this triangle and multiply it by 5. We're going to find the area of this triangle. But first, the height, we're going to need to use our trig ratios. So we have a 36-degree angle, and we're looking for the adjacent side, and we have the hypotenuse. So we need adjacent and hypotenuse, which you can see is cosine. So cosine 36 degrees is equal to the adjacent side over the hypotenuse. And do the algebra on that, and we get 2 times cosine 36 degrees. So we found the height of the triangle. And now the base, step 3, we need x, and we have the hypotenuse. We need opposite side of the 36-degree angle and the hypotenuse. So opposite and hypotenuse is sine. So sine 36 degrees is equal to x over 2, multiply both sides by 2, and we get 2 sine 36 degrees. Now we don't want x, we want b, the base, the total length there. So 2 times x, b is equal to 2 times 2 sine 36 degrees, and b is finally equal to 4 times sine 36 degrees. So now we have the base, and we can get rid of these trig ratios now, so we have more room. So the fourth step is to now find the area of the triangle. And again, I just want to be absolutely clear, we're finding the area of this triangle. So don't be confused by that. There's 2 ways to do it. So area of the triangle is 1/2 times the base, which is 4 sine 36 degrees, times the height, which is 2 times cosine 36 degrees. Now we can just leave it like that, and now we're going to find the total area of the entire regular polygon, which is 5 times the area of each one of those triangles. So 5 times 1/2, and I should probably use brackets there. Just makes it easier to see. 1/2 4 sine 36 degrees times 2 cosine 36 degrees. Let me move that over a little bit. And now the total area is approximately equal to, and we can get out our calculator. I'm going to use the calculator on my computer. 5, I'm just going to go left to right. 5 times 0.5. Now why is it 0.5? Because 1/2 is just the same thing as 0.5. It's easier to enter into your calculator, and then push equals. Then times 4 equals. Then times 36 and the sine button equals. Then times 2 equals. Then times 36 and the cosine button equals. So we get 9.51. And the units are meters, so 9.51 square meters. So that is the basic process for how to find the area of a regular polygon. Okay, so let's try another one of these. Now in this problem, we're going to, it's the same process, but we're not given the radius. So let's draw these triangles. This is a hexagon. We're given the apothem. So before we were given this length, that's the radius. But in these problems, we're given the apothem. So let me draw, that's just the perpendicular length there. So that's 9 millimeters. That's the apothem. And so we have to, again, find this angle, and I'll call that, again, angle A. So step 1, as usual, the measure of angle A is equal to 360 degrees, because the total rotation around the whole thing is 360 degrees. Whole thing is 360 degrees. Now, there's 6 triangles, so we have to divide by 6. And we get 60 degrees. So that's good news because that's a special angle, so we might be able to use our special angles there. So let's take this triangle out. And so again, this angle is 60 degrees. And we're going to drop down in altitude, as usual, and take out that triangle, the left triangle, doesn't really matter which one. And now we divide and we get 30 degrees. Because again, those angles are the same, these two angles here. And the height we actually know is 9 millimeters. Again, if you drop this down here, we know that that's the apothem. And then this side we definitely need, we're going to call that x as usual. And so we're going to use this side and this angle to find the base. We already know the height. So these problems are going to be a little easier. Now, if this angle is 30 degrees, that means that we know that this angle must be 60 degrees by the triangle sum theorem. So we definitely have a special triangle. And so remember, the opposite side, if the opposite side is W, then the side opposite the 60 degree angle is W root 3, and the hypotenuse is always 2 times W. Now in this problem, you can use the special triangles if you want, but you can also use these trig ratios. I don't really care for this particular problem, but you do need to be familiar with those special triangles. So now we're going to find the height. The height is 9. So we're done with that problem, or that part of the problem. I can just put that up here. So we'll call that step 2. And step 3, we're going to find the base. To find the base, we're going to use, again, the special triangle. So now we're looking for W. Now this is something that we didn't do in the previous classes. We did do this in, I believe, the class on special triangles. I was trying to avoid this, but we have to use the root 3 now. So we know that this side is equal to 9. We want to find W, so we're going to have to set W root 3 equal to 9. And then divide both sides by root 3, and we get 9 over root 3. And I'm not going to bother to rationalize that in this class. So now we have W. Why do we want W? Because now W is the base of that triangle, and we just multiply it by 2, and we get the base of the triangle we're actually looking for. So x is equal to W, which is equal to 9 over root 3. But we don't want x, we want 2 times x. So 2 times 9 over root 3. And this is just basic math. 2 over 1 times 9 over root 3. Multiply across, and you get 18 over root 3. A lot of students have trouble with that, but you really shouldn't, because it's just arithmetic. That's why arithmetic is one of the prerequisites for this course. So that was all to find the base. And so again, we're using the bigger triangle, the triangle at the upper right. So we didn't really need those trig ratios, but you can use tangent 30 if you want to use the sine, cosine, and tangent stuff. So now step 4, find the area of the triangle. That's just going to be 1/2 times the base times the height. And step 5, we're going to find the area of the total area, which is, there's 6 of these, so it's going to be 6 times the area of that triangle. So the total area is equal to 6 times all that stuff that we wrote up there for the area of that first triangle. And now the total area is approximately equal to, and we can just get our calculator out. So 6 times 0.5 equals, times 18, because that's in the numerator, equals, and then divided by 3 in the square root button, equals, because the square root 3 is in the denominator, and then times 9 equals, and we get 280.59. And it's square millimeters. So that was a problem where we had the apothem. In the previous problem we had the radius, that's this length here. And in this problem we had the apothem, that's this length here. Okay, on to the third problem. In the third problem we're going to be given the side length of the regular polygon. So the side length is these lengths. We're told that all those lengths are 8. And you know what? I'm going to change this to 7 because I don't want you to get confused by it just because that's a coincidence. It's a number of sides. So there's 8 sides here, an octagon. And as usual, we're just going to draw those triangles. And it's the same procedure. First step, we're going to find the measure of angle A. Total rotation divided by 8, and that's going to give us 45 degrees. You can do that in your calculator if you want to. Now we're going to take that triangle and copy it out here. Now this triangle is a little small, so I'm going to make it bigger there. And so again, that angle is 45 degrees, and as usual, we're going to drop the altitude down. And the side length is 7, so that means this length we don't have to find. That length is 7. That's this length down here. But we do need to find the height, so we're going to pull out one of those triangles as usual, and we're looking for the height. Now this side is going to be half of 7, because again, these two right triangles are congruent. So 7 divided by 2 is 3.5. That's going to be that length. And this angle here is going to be 45 divided by 2. So that's going to be 22.5 degrees. And we don't really have this side, and we don't really need it. So let's color that in there to make sure we know what's going on. Taking that triangle. So now step 2 is going to be to find the height. And you know what, let's start with the base, because we always want to do the easiest parts first. So the base is just going to be 7. So we're going to use the opposite side to find the adjacent side, and of course that reference angle. And adjacent and opposite, that's going to be tangent. So tangent is equal to opposite over adjacent. And I'm not going to do all the algebra here because I did that in the previous class, and it's kind of a long process to show all the algebra. So it's just going to be 3.5 over tangent 22.5 degrees. So now we have the height, and step 4, we're going to find the area of the triangle, which is equal to 1/2 times the base times the height. And step 5, we need to find the total area, which is equal to, this is an octagon, right? So it's going to be 8 times the area of each one of those triangles. So 8 times 1/2 times 7 times 3.5 over tangent 22.5 degrees. And then we just enter that into the calculator. So let me get my calculator out. 8 times 0.5 equals, and again 1/2 is 0.5, just write 0.5. That's easier than writing 1 over 2, and it presents problems if you try to write 1 over 2 on your calculator. Times 7 equals, times 3.5 equals, and then divided by 22.5, and the tangent button, and then equals, and we get 236.59. So it's approximately 236.59, and our units are feet. So square feet. All right, let's have you try one of these problems. And before you try one on your own, you might want to take a screenshot. Again, if you didn't get a screenshot of these, well, you have that information on the left, and you have the first problem that we did. And you can also get a screenshot of these or take a picture with your phone, and you have those to reference. Now we're back to the radius. So again, be aware the radius is the distance from the center to a corner. So be aware that we're going to I think we're going to get a 30, 60, 90 triangle again. So you can use this relation if you want, the 30, 60, 90 relation. But if you have problems with that, remember, you can just go back to these yellow trig ratios that I wrote at the bottom. So you can do it either way. So go ahead and attempt number 4. I'll leave number 1 in the window, and when you come back, we'll do it together. All right, we're back. So we'll draw the center, and we have all these triangles, and we're going to call this angle A as usual. Step 1, measure of angle A is equal to a complete rotation divided by 6, and we get 60 degrees. And we're going to copy that triangle and put it off to the right, make it a little bigger. Again, so that angle is 60 degrees, and drop an altitude, and we're told that the radius is 3, so that means this side is 3 and this side is 3, and these sides we're going to call x as usual. And now we have to take one of those right triangles out. It's going to look something like that, and of course we can divide 60 in half and we get 30 degrees, and this automatically becomes 60 degrees. But don't confuse the angles. We're taking this triangle here and it becomes that. And of course that's a right triangle, and we need h, the height, and we need x. And of course we're given this side. So step 2, let's find the height first. I think I'm going to use the special triangle relation. So remember, side opposite 30 is w, side opposite 60 is w root 3, and we have 2w. So we don't really need any of the sine, cosine, and tangent if you don't want to use that. So we know that 2 times omega is equal to 3, and omega is equal to 3 over 2. That's another way to do it. You can show that with algebra. And the height is equal to omega times root 3, and omega is equal to 3 over 2 root 3. So we found the height. Step 3, we're going to find the base. X is equal to 3 over 2. And of course the base is equal to 2 times x, so the base must be equal to 2 times 3 over 2. And that just equals 3. So I can section that off. And step 4, area of the triangle is equal to 1/2 times the base times the height. And then part 5, the total area is equal to, and we have 6 triangles there, so 6 times 1/2 times 3 over 2 times root 3, so on and so forth. And we just have to enter that into the calculator. So I'm going to get my calculator out. 6 times 0.5, remember 1/2 is 0.5, then equals, times 3 equals, times 3 equals, divided by 2 equals, times 3, the square root button, equals. Round off to the nearest hundredth, so we have 23.38. 23.38 square centimeters. So if you got that answer, good job. If you had a fraction, because of the fractions, you may have had a little trouble with that, but I can't avoid fractions. I can't always protect you from fractions, so if you had trouble with that, I'm sorry that I had to give you a fraction on that problem, but you're just going to have to learn to deal with those. On to number 5. Now in number 5, you're given the apothem, so I just want to give you a review. The apothem is the distance from the center to a side. Okay, so that's going to be the height of each triangle. So now be aware in this problem, when you divide 360 by 7, you're going to get a weird number. It's going to be 51 point, and it's just going to go on and on and on and on. So rather than have to deal with that, you can just write 360 over 7 and just leave it like that. So that is going to be this angle here. Now you want to divide it in 2 as we usually do. So measure of angle A divided by 2, that's just going to be 360 over 7 divided by 2. And when you divide a number, you just flip it. So it becomes 360 over 7. And you change to multiplication. So now it's times 1/2. That's basic arithmetic stuff. So you get 360 over 14. And if you want to, you can reduce that, so it becomes 180 over 7. And you can use this. You can use either of these in your when you carry in your calculations and when you show your work. Instead of writing the angle as a decimal, you can just write that as 180 over 7. And that way, when you go to do the calculations, you're not going to have any round off error. So I know that that's kind of strange. I know you don't want to see all that, but go ahead and try number 5. I can't protect you from that stuff in every single problem. You have to do some of those and get used to them. So try number 5, and when you come back, we'll do it together. All right, we're back. So again, we're going to call this angle A. Draw those triangles. So calling it angle A as usual, and the measure of angle A is just going to be 360 divided by 7. And as usual, we'll take that triangle out and we'll copy it. So again, that angle is 360 over 7 degrees. Then we should probably make it a little bigger. And we'll take out half that triangle as usual, drop down in altitude. And now we want to find this angle. That angle is going to be 360 over 14 degrees. Now again, if you're not sure about the math on that, you can just go to my arithmetic course. So what do we have here? We have the hypotenuse 4, so that's this length. And this side is called x and x. And we have x here. And so we have everything that we need. So let's start with the easy stuff. Height, that's just going to be 4, because that's the hypotenuse. And the base, that was step 2. The base is going to be, we're going to need opposite of that angle and adjacent, so that's tangent. And this is where it comes in handy, keeping this fraction here. We don't want any round off errors, so we're going to write 360 over 14 degrees, tangent of that. And it's probably best to put that in parentheses, equals side opposite over the adjacent. And then, of course, x equals 4 times tangent 360 over 14 times 4. And you know what? I'm just going to write this as 180 over 7, so I don't have to keep writing a 2-digit number on the bottom. So again, we just reduce that fraction, degrees. And the base, of course, is 2x. So we have 2 times 4 tangent 180 over 7. And so the base is 8 times tangent 180 over 7. So I know dividing by 7 was kind of a pain there, but you see, if you just keep it with you there, it's not that bad. Step 4, area of the triangle is equal to 1/2 times the base times the height, and total area is equal to the area of the triangle times 7. So 7 times 1/2, 8 tangent 180 over 7 times 4. And now we just have to use our calculator. So I'm going to get my calculator out. Now, you may not get the right answer if you don't enter this properly in your calculator. So just to be on the safe side, I'm going to enter 180 and then divided by 7 first equals. Then I'm going to do all the other stuff. So if you get the wrong answer, that's okay. Just go back and do it the way I did. So then push the tangent button. And then times 4 equals. And then times 8. So I'm just kind of working inwards and then out. And then times 0.5 equals, and then times 7 equals, then we get 53.94. 53.94, and the units are square inches. So if you got that answer, good job. If you didn't get that answer, then you may have not entered it into your calculator correctly. So just go back and figure out what that's going to be. Alright, so again, I'm sorry about that dividing by 7. You didn't get a whole number there. But again, sometimes that just happens. Now, in number 6, we're given the side length. And I want you to understand that this is a regular polygon, and we can solve it the way that we solved it before. And we're going to do that by adding up the area of those 3 triangles. But I also want you to be aware that technically we don't really need that method, because in these problems, you know, we found that this angle was 60 degrees. That was 60 degrees there, but obviously if that's 60 degrees, then by the triangle sum theorem, these angles have to be 60 degrees also, and by the isosceles triangle theorem. So these are equilateral triangles. So we already found the area of one of these triangles using the methods that we used here. So we could just use those methods on this triangle and drop down an altitude and just do it that way using a 30, 60, 90 triangle and so on and so forth. But just to get practice with this method, I want you to use the method where you actually divide it up into these triangles, because this is an example of a regular polygon. So go ahead and try number 6, and when you come back, we'll do it together. Alright, we're back. So we'll find the center, draw those triangles, and this angle, of course, is going to be angle A. The measure of angle A is 360 over 3, which is 120 degrees. And we'll take that triangle out. And of course, this angle is 120. And dropping an altitude. And we have the side length, which means that we have the base. So we don't have to worry about the base. We already have it. It's 6. We just need to find this height. So let's take one of those triangles out. And if we divide by 2, we get 60 here. And of course, we're just going to divide by 2 to get this length. We're going to need that. And we're looking for the height. And we know that's a right angle. And we're pretty much ready to go at this point now that we have our triangle. So the base, we'll start with that one, because that's the easiest. Always do the easiest part first if you can. So the base, base is just equal to 6. Now we'll do the height. Now obviously this is a 30, 60, 90 triangle, and we have the side opposite 60, so that's going to make things a little difficult because we have to, let's write our special triangle. Opposite 30 is W, opposite 60 is W root 3, and obviously the hypotenuse is 2W. So the opposite side of 60 is 3, so that means that W root 3 is equal to 3. We have to divide both sides by root 3. We get 3 over root 3, and I'm not going to make you rationalize that. So that is W, and W is the height. So putting a little divider there, the height is equal to W, which is equal to 3 root 3. So now that we have the height, we can go on to step 4. The area of the triangle is equal to 1/2 times the base, which is 6, times the height, which is 3 over root 3. Total area of the entire polygon is equal to the area of the, 3 times the area of the triangle, because there's 3 triangles up here, right? 1, 2, 3. So the total area is equal to 3 times 1/2 times 6 times 3 over root 3. And we get out our calculator. Three times 0.5 equals times 6 equals times 3 equals divided by 3 square root button equals, and we get 15.59. So if you got 15.59, good job. And the units are square centimeters. Okay, now we're going to learn how to find the surface area of regular pyramids. So you probably know what a pyramid is, but the technical definition is it's a shape with a polygon base and triangular sides with a common vertex. This top side is called the vertex. And these sides over here are called the lateral faces. And we're going to study special types of pyramids. They're called regular pyramids. And what that means is that the base has to be a regular polygon. In this case, it's a square. And the actual height of the pyramid is from the center of the regular polygon to the very top, the vertex. And the slant height is just the height of these triangular sides. Now, when you're dealing with a regular pyramid, these sides are always isosceles triangles, and they're always congruent isosceles triangles. So this triangle is congruent to this front triangle, and the side triangle and the back triangle, and so on and so forth. So that's the basic idea of regular pyramids. So let's find the surface area. And again, we're dealing with surface area here. Let's find the surface area of this regular pyramid. You see it has a triangular base. And we're told that these are regular, so that means that it's an equilateral triangle on the bottom. So let's do the easy part first. Step 1, we're going to find the area of the lateral faces. And you see we have the sides of this equilateral triangle, they're all 2. So that means that this side is 2. That's the base of this lateral face here, you see. And the height, we're told, is 5. And the height is the same for all the lateral faces. So we just say, we'll just put area of triangle is equal to 1/2 times the base, which is 2, because this is the base here, and the height we're given is 5. So again, these are the isosceles triangles on the sides, the lateral faces, and that equals 5. So the area of the triangles equals 5. Now we want the area of all the sides, which is going to be equal to 3 times the area of each triangle. So 3 times 5, which is 15, and I'm just going to the right because I want to save room here. So as you can see, finding the area of the lateral faces was really easy if you're given the height and the base of those. So now, step 2, we're going to find the area of the base. So regular polygon base. So now we're moving on to finding the area of the base, and the base is, so there we go, we have something like that, regular polygon, and we're going to write that center and then draw those triangles. And again, this is kind of a long way to do it, but that's okay because that's the whole, again, that's the whole point of the class. So complete rotation is 360, and I'm going to do step 2A. So if we call this angle A, then obviously the measure of angle A is equal to 360 divided by 3, which is 120 degrees. And I'm going to pull out that bottom triangle there. And again, it's not going to look exactly correct, but you get the point. So then if we drop it altitude, take that triangle out, we have 60 degrees and 30, and you can see that this is going to be a special triangle. Now it says the sides are 2, so what that means is that this side's 2, this side's 2, this side's 2. So the base, we already know, is 2. All we have to do is find the height. We can cut this in half, and so we get 1 here. And this is a 30, 60, 90 triangle, so we can get out our special triangle. And we have 60 here and 30, so W root 3, and 2W. So we need to find W. And we know that this side, the opposite 60, is 1. So we can set 1 equal to W root 3. And just doing the basic algebra there, we see W is equal to 1 over root 3. So that's the height of those triangles. I'm going to label that as the height. We'll call that step 2B. And omega, or the height, is equal to omega, which is equal to 1 over root 3. And now we want to find the base. The base is that's easy. The base of that triangle is just 2. So now we have everything that we need. And by the way, that was step 2C. So now we're out of room, but that's okay. We can just do a little arrow up here. Remember, you have to do that quite often in math courses. Running out of room is very common. So now we want to find the area of this triangle here, which is equal to 1/2 times the base times the height. So the area of the polygon base is equal to 3 times the area of each one of those triangles. So area of polygon, the area of the polygon base is equal to 3 times that stuff up there. At this point, there's a lot of different ways you could do this. You could just enter the number into your calculator, but I'm going to go ahead and combine those. So 2 times 1/2 is just 1, and then you're left with 3 times 1 over root 3, which is just 3 over root 3. So that's something that we did not do in the previous problems. I never required you to actually simplify these expressions, but in this case I think it's going to be good for us. So at this point we're ready to go. And by the way, that was part 2D, and then this was part 2 A, B, C, D, E. So now we're going on to part 3, where we just add those two numbers. So we have the area of the polygon base, and we have the area of the lateral faces. So the area of the pyramid is equal to the area of the polygon base plus the area of the sides. And the area of the polygon base we just found is 3 over root 3. And the area of the sides we found up there is 15. And the units are square feet. Now, you might be tempted to put that in your calculator, but we don't really need to. I mean, that's the answer. That's the exact answer, so we can just keep it like that. So that's how you do these problems. Let's do one more of those together before you try one on your own. Now we've got a regular pyramid with a pentagon base. And so we're going to start with the easy part, the lateral faces. And area of the triangles, area of one triangle is equal to 1/2 times the base times the height. Again, this is the base, which is 4. All those bases are 4 of the height. So then we get 16. And the total area of all the sides is equal to 5 times, because there's 5 isosceles triangles, so 5 times that area we just found, 5 times the area of the triangles. And to save room, I'm just going to write that over here. So 5 times 16, which is 80. So we found the area of all the lateral faces. And now we're going to find the area of the regular polygon base. And same situation, same thing we did before. You're going to find this angle by taking 360 and dividing. So we have 2A Measure of angle A is equal to 360 divided by 5, which is 72 degrees. And we're going to take out one of those triangles as usual and drop down an altitude. Then take out that left triangle. So we have height, and the base we already know is 4. So this length is 4, which means that this length here is 2. And if that angle is 72 there, divide it in half, we get 36 degrees. This is all familiar from what we did before. And so we can use the trig ratios to find the area of the bases. So height, now we're on 2b, part 2b, and we're going to need tangent 36 degrees is equal to opposite over the height, and solving for the height we get 2 over tangent 36 degrees. So I've got the height now. Now we need to find the base. We're at a room, so I'm going to go up here onto step 2C. Sorry if things are a little disorganized here, but sometimes that happens. Your work can't always be perfect, so don't get all nervous if you have to do a test and your work is not completely perfect. Sometimes that happens as far as the order of what you're doing. So now we're going to find the base, and the base is simply 4 because we have the base down here. That's the side of the polygon. And so part 2D, area of the triangle, that one triangle is equal to 1/2 times the base times the height. And we want the area of the whole polygon base, which is 5 times the area of that triangle. So 5 times all that stuff up there, so 1/2 times 4 times 2 over tangent 36 degrees. I'll move that over a little bit. And now we could just simplify that, but we didn't really simplify that expression in the first problems we did today, so I'm just going to write an approximation for that. So I need the calculator, and we have 5 times 0.5 equals times 4 equals times 2 equals divided by 36 tangent equals 27.5276. 27.5276. Whoops. Because we're in an intermediate step, so we need to carry out more decimals. And then we have finally part 3. Part 3 is the area of the surface area of the pyramid is equal to the area of the polygon base plus the area of the sides. And that was 27.5276 plus the area of the sides, which was 80. And if you add that up, that's pretty easy. You can probably do that in your head. By the way, that should be an approximately equal to sign. So that would be 107.5276. And we're going to round to the nearest hundred, so that would just be 53. And the units are inches, so inches squared. And I know that seems like a long process, but part of the reason it seems like a long process is that I'm, explaining every single step. You don't have to explain the steps when you do it. You have to show some work, but not all of it. Now it's time for you to try, and I have good news about number 9. I know what you're thinking. You're thinking, I really don't like this stuff. This is nasty. This is horrible. I don't like it. Well, we're only doing 2 more problems. And the good news is, for this problem, there's a square for a base. So I'm not going to make you do all that stuff, you know, where you divide it into 4 triangles. It's so easy to find the area of a square base. You just, it's just 6 times 6 is 36. So hopefully that'll make it easy for you on that one. And you can take screenshots of these if you want to. And so again, number 9 is going to be really easy, way easier than the previous problem. So try number 9, and when you come back, we'll do it together. All right, we're back. So first step, we're going to find the area of the lateral sides, or lateral faces, whatever you want to call them. And area equals 1/2 base times height, which equals 30. And we want the area of all the sides, so that equals, it's a square, so there's 4 isosceles triangles, so 4 times the area of each triangle. That's going to be 4 times 30, which is 120. So we're done with the lateral faces. Now the bottom, the base is going to be even easier. So we want the regular polygon base, and that area of the polygon base is just going to be 6 times 6. Probably should use parentheses. 6 times 6, which is 36. And step 3, area of the pyramid, surface area of the pyramid is equal to the area of the polygon base plus the area of the sides, and that equals area of the polygon base is 36, area of the sides is 120, so we get 156 square feet. So that was kind of an easy one. I purposely gave you an easy one because I know you're probably getting tired of all this type of stuff, and you know, I can't avoid hard problems in every one of these. Sometimes you have to do the arithmetic. All right, so try number 10, and for number 10 we have what looks to be 1, 2, 3, 4, 5, a hexagon base. So you're definitely going to have to use the methods that we used before to find the area of the base. So try number 10, and when you come back, we'll do it together. All right, we're back. So first we're going to do the lateral faces as usual. That's the easy part. And so area of one of the lateral faces is equal to 1/2 times the base times the height, which is equal to 12. And the area of all the sides together is going to be 6 times the area of each one of those triangles. So 6 times 12 is equal to 72. So we're done finding the area of the faces, lateral faces. So now we're going to find the area of the regular polygon base. And to do that, we're going to pull out that hexagon, and hopefully I can draw one that looks remotely like an actual regular hexagon. That looks about right. So again, it's just the same situation. We're going to find the area of each one of these triangles and then add them up. And this angle, we'll call that angle A as usual. And the measure of angle A is equal to 360 divided by 6, which is 60 degrees. And we're going to take that triangle out. We have 60 degrees here, but we're going to drop an altitude. And this side is 4. Now we're going to take out the left triangle, and this side is half of 4. And we're going to make sure that we know which triangle we're pulling out here. I know you probably know that already, but I just want to write this so you can go back to your notes. And we're looking for the height, and we have this angle here, which is 30 degrees. So we have to use a special triangle, it looks like. So we're going to use a 30, 60, 90. And we have 2w as usual, and w root 3. So height, that's step 2b. W is equal to 2, and the height is equal to w times root 3, which is equal to 2 root 3. And so now we're going to go up here because we obviously are out of room. Now we're going to find the base. So the base we already have is 4. Step 2D. We're now going to find the area of one of those triangles, which equals 1/2 times the base times the height, which is 2 root 3. And the area of the polygon base, this is step 2E, is equal to 6 times the area of one of those triangles. So area of the polygon base is equal to 6 times 1/2 times 4 times 2 root 3. And we can go ahead and simplify that. And again, I know we didn't simplify that in the first problems we did today, but in this case I think it would be best. So multiplying all that together, 6 times, well, we can do the inside part first. You can do it a lot of different ways. 1/2 times 4 is 2, and then 2 times 6 is 12, and then 12 times that 2 right there is 24, and then the root 3 just hangs out there. So at this point, we need to go to step 3, and we know the area of the pyramid is equal to the area of the polygon base plus the area of the sides. And we know the area of the polygon base is 24 root 3, and the area of the sides we found up here is 72. And so that's pretty much the answer. We can get out a calculator and kind of approximate the answer, but these problems didn't actually tell us to round off to anything, so we can just leave it like that. So that's meters squared. So I know that's an involved process. I get that. But, you know, you're perfectly capable of doing this. Students are typically going to have trouble with this, simplifying that. I think it's pretty easy. You just take these constants and you just multiply them together. That's not that hard, and just keep the root in front. Or you can, you know, just enter this into your calculator, get the answer, and then compare this, whatever that is in your calculator, to what you got, and see if you got the right answer. So, again, if you got that right, good job. Let's go on to the last thing we're going to learn today, which is geometric probability. And geometric probability is going to be really easy compared to the things that we just did. So probability we haven't really gone over in any of my courses yet, but you probably know quite a bit about probability just by what you've heard in our culture. It's such a useful thing that you've probably heard, well, this has a 50% probability or 100% probability, so on and so forth. But probability is just a fraction. It's just a number. But remember, a fraction can be written as a percent or a decimal, so you might see it as those two also. And percent goes from 0 to 1, and 1 means that it's definitely going to occur, and 0 means it's definitely not going to occur. And 0.5 or 50%, 1/2 probability, that means that it's equally likely to occur and not occur. So if you've never seen probability, that's just what that means. So let's say that you're going to flip a coin. It's a 50% chance that you're going to get tails. Or you might say, well, I'm definitely going to go to a concert. So and you're absolutely sure you're going to go. So it's a 100% chance that you're going to go. So that's just what probability means. And if you know that you're not going to go, if you're absolutely sure you're not going to go, that means it's a 0% chance that you're going to go. So that's what probability means. Now that's kind of unlikely because there's always a chance that you might go somewhere or something. So it's, in reality, it will be close to 0, but not actually 0. But anyway, you get the point on that stuff. So now we're going to do probability in area. So if a region M contains region Q, so this M part contains the purple part inside it, then the probability of the randomly chosen point in M, so if I just choose some random point like here, the probability that that point will be inside here is the ratio of the area of Q, if you can find this area, to the area of M. So I know that seems kind of hard to think about, but for example, if you had a very simple shape of a box, and the box looks something like, the bottom of the box looks like something like this, and you divide the bottom of the box in half, and then you throw something randomly inside the box, it's about a 50% chance that it would land here, and about a 50% chance that it would land here. So what you could do is you could take the area of the bottom of this part, we call that, we'll call this area L, and we'll call this area N. The area of L divided by the total area total is going to be 1/2, or 50%. And so that's how this works. If you want to find the probability it's going to land in here, you just take this area and divide by the total area. So it's a very simple idea. So we can say you're finding the area of L and N. All right, so that's just one example there. So let's try some practice problems. If you didn't understand all that, that's okay. You're going to see how this works. So we want to find the probability that a randomly chosen point in the figure, so the point has to be inside this rectangle. Okay, it has to be inside here, so we're going to drop something in there. And what is the probability that that point that we drop in there is going to land in this circle? So again, it's equally likely to land anywhere in this rectangle. We just need to know the probability that it's going to land in the circle. So first thing we're going to do is find the area of the shaded region. And that's going to be equal to the area of the circle, which is equal to pi r squared, which is equal to 25 pi. Then the second step is to find the total area of the whole figure. So we found the area of this part, that's 25 pi, and then we're going to find the total area. So the area of the total is going to be the area of the rectangle, which is 18 times 10, which is 180. So now step 3, we're going to find the probability, which is the area of the shaded region, divided by the area of the total area. So the probability equals area of the shaded we found is 25 pi, area total is 180, and at that point you can just get out your calculator. So now we have 25 times pi equals, and then divided by 180 equals. Now it says to round to the nearest thousandth up there, so that would be 0.436. So the probability is approximately equal to 0.436. So what that means is that it's a little less than half the likelihood that it's going to land inside this shaded region if you just drop something randomly in there, or just pick a point randomly. You're not necessarily dropping anything, but you're picking a point randomly. These concepts are kind of they're all in the head. I don't know if there's not really a perfectly real world application of any of this stuff. This is called probability theory. So on to number 12. Step 1, we're going to find the area of the shaded region, which is the area of the square you see, which is 8 times 8, which is 64. And then we're going to find the area, the total area, which is equal to the area of the triangle, which is equal to 1/2 base times height, which is equal to 150. Step 3, the probability, I want to move that down a little bit. The probability is equal to the area of the shaded region divided by the total area, which is the shaded region is 64 and the total area is 150. So we can get out the calculator for that. 64 divided by 150 is that, and if you round to the nearest thousandths, that would be 0.427. So approximately 0.427. So our answer was very similar to the previous problem. That just means it's about a little less than 50% chance that it's going to land in that square. Remember, these pictures are not exact, so don't criticize me because the pictures are not exact. It's not really a big deal. The important thing is that you're getting the idea. And you could change these to percentages, but then the whole idea of rounding to the nearest thousandth would change, so I don't want to mess with that. So let's try two more of these before you do it on your own. This one's going to be a little different. The area of the shaded region is the area of the rectangle minus the area of the parallelogram. And this is something that really kind of confuses students. You have to find the total area of the whole thing, then subtract the area of the parallelogram, and that gives you the area of the shaded region. A lot of students really don't like that. You know, it's not an easy thing to conceptualize in terms of the actual squares that you're counting, you know, and that's why you have to just memorize those formulas. But if you take this whole thing and then you just cut out this part with scissors, then you're left with the purple part. That's all we're saying. It's very easy. So the area of the shaded region is equal to the area of the rectangle, which would be 10 times 5, minus the area of the parallelogram, which is base times height, so 6 times 3. So the area of the shaded region is equal to 50 minus 18, which is equal to 32. Now step 2, as usual, we have to find the total area. The total area is equal to the area of the rectangle. That's the whole thing, which we already found is equal to 10 times 5, which is equal to 50. Now, step 3, the probability is equal to the area of the shaded part, as usual, over the total area. And the area of the shaded part we found is 32, and the total area is 50. So then we can just go to the calculator. 32 divided by 50. 32 divided by 50 equals 0.64. So we don't have to worry about rounding because it's exactly 0.64. And if you were to change that to a percent, it would be 64%. So it's a little bit greater than a 50% chance that you're going to land, that the point chosen at random is going to be in that purple part, which makes sense because the purple part is bigger than the parallelogram part. Okay, now the difference with that problem is, like I said, finding the area of the shaded region was a little harder than the previous problem. So let's do one more of these before you try some on your own. So the area of the shaded region is equal to the area of the circle minus the area of the triangle. Do you see why that is? You get a piece of paper that it's a circle, and you just cut out this triangle part, and you're left with the area of the purple part. So the area of the shaded region is equal to the area of the circle. Now, circle is pi r squared, and r we see over here is 12.1. So that'd be 12.1 squared, and minus the area of the triangle, and the area of the triangle is base 1/2 base times height. But what is the base? Now this is a little tricky. You see the base, let me get a different color here. The base of the triangle, you can consider it to be this side. You can consider it to be really any side, but obviously we want this side. That's going to be easiest. and this is the height, which is perpendicular to that base. So this side, it looks like we don't have it, but we do, because we know this is a radius, which is 12.1, because we know this is 12.1, and we know this is a radius. So you just add 12.1 and 12.1. So 12.1 plus 12.1, and then you multiply by the height, which is 12. So times 12, and I'm going to move that over. So let's go to the calculator. It's probably best at this point to just write an approximation for each of those expressions. So 12.1, and then push the square button, and then times pi equals. So we're going to carry that out about 4 or 5 decimal places. So 459. So approximately equal to 459, and then minus, and we want to use order of operations, so we have to add 12.1 plus 12.1, and that's pretty easy. That's just going to be 24.2. So 24.2 times 12 at the right equals, and then divided by 2 equals, or times 0.5, same thing. So we get 145.2, and then we can just enter that in, and we get that number. Now step 2, we have to find the total area, which is equal to the area of the circle, which is equal to pi r squared, and we have that number. It's approximately 459.96058. And now we're going to find the probability, which is the area of the shaded region over the total area, which is equal to area of the shaded region is 314.76058, and total area is 459.96058. And so we just divide those and we get 0.684. So 0.684. Alright, so sorry about all the decimals in that one. So now it's time for you to try. 15 and 16 are going to be pretty standard problems, so attempt number 15, and when you come back, we'll do it together. All right, we're back. The area of the shaded region is equal to the area of the triangle, which is equal to 1/2 times the base, if you consider 10 to be the base, times the height. So this is a right triangle. That's why we can do that without a lot of trouble there. And that's going to be 35. Now, part 2, we're going to find the total area, which is equal to the area of the rectangle, which is equal to 15 times 12, and that would be 180. It's just a coincidence we got the same answer as before. And part 3, we have to find the probability, which is equal to, as usual, the area of the shaded region over the total area. And that is 35 over 180. So 35 divided by 180. And we get 0.194. Again, rounding to the thousandth place, 0.194. And that is the probability. So does that make sense? It seems to make sense. The probability is going to land in the purple part is a lot less than 50%. So if you got that answer, good job. So for number 16, just be aware that these tick marks say that those two lengths are the same. So the total length is 10. Be aware of that. Go ahead and try number 16. When you come back, we'll do it together. All right, we're back. Step 1, area of the shaded region is equal to the area of the top triangle, and that is 1/2 times the base times the height. So the base is obviously 4, but the height is going to be 5, because these are the same length, so it's 5 plus 5 is equal to 10. So the height of that triangle is 5. And so the area of that top purple triangle is 10. And the total area is the area of the big triangle, you can call it whatever you want, which is equal to 1/2 times the base times the height, which is the whole length there. So we get 40. And the probability is equal to the area of the shaded region over the total area, and that is 10 over 40, which is 0.25. So we got 0.25. Good job. Now just be aware my triangle is not exactly proportional, so don't worry if it looks a little off there, but it's about 0.25. So we got that answer. Good job. For number 17, remember the area of a kite is 1/2 times the product of the diagonals. And remember, to find the area of the shaded region, you have to take the area of the whole thing and subtract the area of the kite. That's the area of the shaded region. So try number 17, and when you come back, we'll do it together. All right, we're back. Step 1, the area of this shaded region is equal to the area of the rectangle minus the area of the kite, and the area of the shaded region is equal to area of the rectangle is 6 times 11. Area of the kite is 1/2 times the diagonals. So the diagonal, this length, is the same as 6 millimeters. So it would just be 6, and this diagonal length would be the same as 11 millimeters. So that was kind of the trick on that problem. And so we get, I guess I don't have to keep writing that, 66 minus 33, and we end up with 33. So now we have to find the total area, which would just be equal to the area of the rectangle, which is equal to 6 times 11. We already found that is 66. And then the probability is going to be equal to the area of the shaded region, as usual, over the area total, which is equal to 33 over 66, which is equal to 1/2. So it's exactly 50%, and that is the final answer. So if you got that answer, good job. All right, so number 18, go ahead and try that one. Now it's assumed that B is the center of the circle. You're often going to be given problems where it doesn't actually say it's the center, but if you see that dot in the center, you just assume that it's the center. And also 18 is kind of a challenge problem. You're going to have to use your head on this problem, and if you get stuck, that's okay, but give it an honest attempt, and when you come back, we'll do it together. All right, we're back. Part 1, the area of the shaded region is equal to the area of circle, and it's kind of hard to name the circles, so I'm just going to name the circles by the radii. So circle BC minus the area of circle BD. That's not exactly a standard notation there, but you get the point. We're taking the area of this circle, the whole thing here, and we're subtracting the area of this circle in here, and that'll give us the remainder part, the shaded region. So area of circle BC, we're told that BC is 7, so pi times r squared minus pi times, what is the radius of BD? We're told that BD is 4, so 4 squared, and we get 49 pi minus 16 pi, and those are both pi, so we can just subtract them. We get 33 pi. And so that's the area of the shaded region. So step 2, and there's a lot of different ways you could do this. You may have entered that into your calculator or however you want to do that. Now the total area is equal to, and you might say, well, that's not fair. You didn't tell me I was going to get multiples of pi. Well, you're just going to have to get used to this stuff. You're going to see some of this stuff in problems. So the total area is equal to the area of the whole thing, the biggest circle. So the area of circle AB. And so the area of circle AB is just pi times the radius of the biggest circle, which we're told is 10. So we got 10 squared, and we get 100 pi. And the probability is equal to, again, area of the shaded region over the total area. And that is equal to 33 pi over 100 pi. And you can enter that into your calculator, but it's a lot easier if you just cancel out the pi's. So you have pi divided by pi, so you just get 33 over 100. And you could actually, well, actually, no, you can. I was going to say divide by 3, but that's not going to work to simplify it. So now we can just go to the calculator. 33 divided by 100. So 33, if my calculator will open. So 33 divided by 100 equals. And, you know, we didn't really need the calculator for that because, you know, we can just change it to decimal form. You know, if we have a power of 10 in the bottom, that makes it pretty easy to write the decimal. So if you got 0.33, good job. And so that was the class today. Now let's take screenshots of the work we did today to help you do your homework and to study for tests. So get a screenshot of these pages. That's screenshot number 1 and screenshot number 2 and screenshot number 3 and screenshot number 4 and screenshot number 5 and screenshot number 6 and screenshot number 7 screenshot number 8 and number 9. Don't go before you get your homework. Let's take a look at the homework. So get your first screenshot here. And screenshot number 2. And that is the homework, just 10 problems. Remember, get that homework done completely, correctly, neatly, and put it in order in your binder. If you don't do the homework, you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.